bars around your expression. So the definition of absolute value is the distance that a number is from 0. That's the definition of absolute value. When you take the absolute value of a number, you're expressing what the distance is of that number from 0. Remember, when you guys are finding distance, it's always going to be positive. I'm sure that's probably the most common idea that you associate with absolute value. The answer is always positive for an absolute value. So let's say I want the absolute value of 4. How far away from 0 is 4? 4. Because if you look at this number line, right, here's our kind of reference point, you have to go 4 out to the right to get to 4. How far away from 0 is negative 3? 3. Even though the negative 3 is negative, you still have to count 3 little units in order to get there. It doesn't matter whether you're going right or left, distance is going to be a positive number. Alright, this one's a little bit interesting. What is the negative distance of negative 1 away from 0? So this little negative is on the outside of the absolute value, so that's going to stay part of the answer, right, kind of on the outside, and then separate from that you guys will tell me what the absolute value of negative 1 is, which is positive 1. So that's the only way that your answer would actually end up being negative, is if they have an extra negative up front. But absolute value by itself. Okay? How far away from 0 is 0? 0. And then what about that one at the end? It would be negative 5. Again, you want to think of how far away from 0 is 5. It's 5, but that extra negative on the outside makes the answer itself negative. So that's just kind of honing in on the definition of what absolute value is. Alright, now we're going to jump right into the idea of solving absolute value. What does that mean when we're solving? So when the value inside of the absolute value bars isn't just like a single number like we were just seeing, instead it involves a variable, so it's an expression with x or whatever variable, and we're asked to solve, we have 2 different situations to consider. Okay? Why do you guys think there would be 2 different situations? Up here, when we were looking at this, we just had one number, right? We said how far away from 0 is 4. We knew that we were right here, so we just went to the right. Okay? But why would you think that if I had something like x minus 2, something like that, why would I have 2 different scenarios? Okay, so a little bit more specific than that. Yeah, do you know what this number is on the inside? Do you know whether it's positive or negative? Do you know whether to go to the right or the left? No. So we have to kind of take both of those into consideration. So y2 is because distance on a number line goes both right and left. And we have to take both of those into consideration because we don't know what x is. We don't know what that number is that the absolute value is. So you're going to see that when we're solving with absolute value, we're going to have 2 different equations that we have to solve. We have the left situation and the right situation when we're solving. So you'll notice that we often have 2 answers when we're solving. Not always, but often. So here's kind of our definition of what's going on whenever we're solving. So for any real numbers x and y, where y is positive, so remember the distance has to be positive, we're going to think about these 2 scenarios. Okay. So for example, if I have the absolute value of x is equal to, let's say, here I'll write this underneath. If I say the absolute value of x is 4, what could x be? What are the 2 numbers on the number line that are 4 away from 0? 4 and negative 4. Do you guys see? You can go either direction. So because this is representing a distance, you could either go to the left for that distance or to the right for that distance. So it could be either 4 or negative 4. Okay? So that's why we always have 2 answers. You can go either to the right or to the left. Before we actually go on to do the solving, I just want to remind you guys really quickly about the covariance multiplication. That already in last unit, but I just want to remind you so we have that foundation before we move on to actually solving. So let's say you guys have this kind of scenario where it's absolute value of x equals 3. We were just talking about that. It could be, the value of x could be 3 or negative 3. We're actually going to use, I should have said or, it's going to be and. I have a little gap between these because we're going to put a word in between them. So whenever you guys have inequality, it's going to be both 3 and negative 3 at the same time. Both of those are going to be your answer. How do you think I would graph that? Dots, right? Dot right here, and a dot right here. Again, we talked about this last unit as well. Whenever you guys have equality, it's just equal to numbers, you just draw closed dots on the numbers. Now, you can remember, how do you write integral notation when you have two separate answers? Comma? Nope.
Bracket.
Nope. Yep. When you have individual numbers, it's just this number and this number independently, nothing in between, nothing on the outside. It's just negative 3 and 3. They each get their own little brackets for the notation. Nope. What about set builder? Squiggle bracket, x such that x. Yeah, there you can write a comma because you're writing a list. That's fine. That's where the comma would come in. That's how you would use equality. So this part of the chart here is separate from everything underneath it. This is equality, and everything underneath it is inequality. So you can see the greater than and the less than. These are going to be a little bit. All right, if I have that the absolute value of x is less than 3, I'm going to use the word and still. So this is saying that the distance from 0 is less than 3. So the number that you're using has to be less than 3 and greater than negative 3 in between those two ideas. So how do you think that I would write, or sorry, draw this? Yes. So remember, if the distance from 0 is less than 3, then it can't go past 3 on either side, right? Because it's less than. So it's going to be open circle because it's not including 3 or negative 3, and it's going to be in between. So think whenever you guys see the word and for an inequality, think this. Your graph will look like this. It's inclusion. You want to include people. They're all together. Everybody inside, they're hugging each other, right? It's like a happy party right there. All right, how do you think I would write that in integral notation? Based on the graph now. Yep, that's why I always suggest, even if the question has it so you write the notation first and the graph second, always graph it first. So you guys graph it. See how this makes it a lot easier to write the notation? So always graph it first. All right, what would the set builder look like? Inequality sandwich. Use that inequality sandwich whenever the x values are between two numbers. Correct, call it inequality sandwich. Alright, this next one, what's the only difference? It's not equal to. So almost everything is going to be the same except for what about the graph? Closed circles, but the general idea is the same. Negative 3 and 3 closed circles. Which we follow on. Okay, what would change about my interval notation? Instead of parentheses, brackets. Because I'm still going from negative 3 to 3, but now it's equal to those two numbers. And that was the only difference I would make with the set builder. You would just add the equal to underneath the inequality. These are virtually the same, just have to remember to change it with the equals added into the picture here. Then we switch to the greater than. Okay? All of these have the word and. What do you think the word's going to be for a greater than? Or. I emphasize that because that's the way it's numbered. Greater. Okay, everything else is and except for greater than. Right, so this one, the distance has to be more than 3. So when you're at 0, the numbers that we want to be the solution have to be more than 3 away from 0. So these are going to be open circles, and then I'm going to draw a line in between. They're going to be separating. So the word and is inclusive. It brings things together in a nice little happy family where they're contained inside of those little numbers. But for or, it separates them. So it's splitting them apart and they go away. They're not very happy. So think about and as that line in the middle, and or as they're split apart going outside. use my hands a lot for that. All right, what do you guys think the union? Good. You guys see this empty gap right here in the graph? Empty gap. You saw that on day, if it was either day 1 or day 2 from that unit. When there's a gap there, you got to go for it. And then the interval, the set builder notation is very simple. All you guys have to do is write this. Just say x is greater than 3 or x is less than negative 3. Just rewrite it for word what we heard. Just like this one right here is very similar to the less than. Once you guys add the greater than or equal to, only thing you have to add in is now that equal to idea. So it's going to change. Where's our word still? Greater than. And then what is my graph going to look like? Close circles. Arrows away from each other. What changes about my integral notation? Do I put brackets around the infinities? No. Still, whenever you guys are using infinities, they're always parentheses. But the 3's are now being included, so you're going to use brackets around the 3's. And then lastly, the only thing that's going to change about set builder is the way that you write the notation. So x such that x is greater than or equal to 3 or x is less than or equal to negative 3. Just add a little equal to. Okay, so this shouldn't be new. We talked about set builder. We talked about graphing and interpreting graphs with the set builder and interval notation from last unit. This is just an extension in the context of absolute value. So make sure you guys are still okay with those ideas. All right, now we're actually going to get into this idea of how to solve. So I came up with this little 3-step process. They all start with S, so they're easy to remember. Your first step is simplify. Again, I'll start with S. So it's simplify, split. Simplify, split. Okay. Let me reset the word. What do you guys think the last one is? I said solve already. Simplify. Split. Solve. It's easy to remember, they all start with S. So the simplify step means that you guys need to get the absolute value by itself by using inverse operations. So I like to refer to the absolute value as the castle, as those walls. So you want to get the castle by itself. You want to move the peasants and the knights and all the people. You don't want them near the castle, so you're going to move them to the other side of the expression. So for example, if I start here, if this is where I started, what's on the side with the castle that I don't want there? The 2. I don't want that there. I want the castle by itself, the absolute value by itself. So I subtract that, and that gives me my step number 1, gives me 5. Everybody see how I did that? Okay, that's the simplify step. You may have to do more than just one thing. You may need to divide, subtract, multiply something. You have to do multiple steps. But as long as you have the absolute value by itself, you're good for step 1. Then step 2, remember how I said there are 2 different scenarios? You have the left and the right. So what you guys need to do is you're going to split this into 2 different equations. And it's really easy. You're just going to take this and write it the exact same way without the absolute value bars. And then you're going to take that equation and write it again, but make the number on the end big. That's it. Right? This is to the right, this is to the left. See that? One needs to be positive on the right side, one needs to be negative, and you're good to go. Once you write those 2 different equations, really basic algebra, solve those real quick to get you your equations. Okay? So simplify, split into your positive, negative equation, solve them using some basic algebra steps, and then you get your 2 solutions. And because this was equality, I used the word and. X equals 3 and x equals 3. you have to be careful whether you use hand or board. That's all there is to it. Okay? Alright, so let's look at this first one. We're going to solve, and then we're going to write the solution in both notations and then graph it, but we're going to graph it first. It's usually easier. So what's the first thing that I would do? My simplify step. Divide by 2. So that's going to get me x plus 2. Absolute value of x plus 2 equals 5. Simplify the cancel, or absolute value by itself. Now what do I do? So I have positive version and the negative version. You no longer write the absolute value bars when you guys do this split. Then what? Subtract the 2 in order to solve both of them. So I would get x equals 3 for this one, and x equals negative 3 for this one. What's the word that I would use? And or. Okay, that's all. Now we're going to graph it. We're going to graph it first, and then we're going to write the. So I didn't number the number line on purpose. You guys can just pick 2 points. I call this -7 and call this 3. I don't want you guys to spend so much time drawing all these little dashes. Like if the answer is like -21, it's better at forever drawing dashes on the number line. So don't do that. Just pick 2 random dashes that you really like. Name one, the one on the left, and name one on the right. Now it would be incorrect. This is where you guys have to be careful. It would be incorrect if you called this one 3 and this one -7. You guys understand why? You have to number it in order the same way you would see it on an actual number line. So please make sure you have that correct. So this is the graph. Now, how would I write these step order? X such that x equals, I would prefer that you guys write them in the order that you see them on the graph. So, in confusing order. And then what about set builder? Oh, interval, sorry. Interval notation. I already did that. Yep. On the bracket palette for each of those little answers. And now we'll process that. Question? Okay, next one. What would I do? Step 1 is to simplify. So how would I get the absolute value piece by itself? Subtract the 5 and divide by -4. So if you guys need to do that in 2 separate steps, that's fine. I'm going to do it in 1. So if you subtract the 5, it becomes -16, and then -16 divided by -4. You need to do it in 2 steps, it's fine. Just saving your homework. Great, once the absolute value is by itself, what do I do next? Yep, you write 2 different equations, one the positive version and the negative version. Notice that what was inside the absolute value does not change. Do you guys see that? What was inside of the absolute value bars is protected by, because it's a castle, it's protected. The only thing that changes is the number on the right, the number on the end. So it changes positive and negative. Now what? Add 3 and then divide by 2. That would be 7 divided by 2, 3.5. Right? Do the same thing for the other one. -0.5. And when I use the word and, or. Alright. Set builder notation, really simple. Oh, sorry, graph first. Pick your favorite points. I don't really care where, as long as they're in order. Oftentimes I'll give you just a plain line without any hash marks. You just draw 2 hash marks, name them with the 2 numbers that you have, and then draw. I'm not too picky about drawing all those hashes. And oops, that's negative. Write out your set builder. Write out your interval. Same system that we have before. Sorry about that, and not for you. So these are the 2. You guys can write them as fractions too if you would like, but I will typically use decimal. those are the two numbers that you should have gotten. Right, the word and somewhere involved in there, and then you guys write set notation. That, and then again, you guys can pick two little dashes on there. Okay, everybody get that? Yes. It should be -7 divided by 6. Rounding. Any other? 1 or 2 decimal points. Any questions about that one? Alright, so for number 4, this one's interesting. You guys probably, I should have caught you a little bit sooner because this one is an interesting situation. What is it put in after step 1, the simplified? The absolute value of 5x minus 4. Okay. Now, remember how we had that conversation up there? What's the definition of absolute value again? The distance of this inside the absolute value from 0. Remember how we said distance is always positive? This statement is saying that the distance of this value from 0 is -2. That can happen, can it? Is there any value that you can plug in for x that will make the distance negative? Is there any number in the world that will make a distance negative all of a sudden? No. So when you guys see something like this, where you can see that it's equal to a negative number, which is not possible, you guys are going to say no solution. You do not proceed. Once you guys do the simplified step, always check to see if it makes sense. If you have a negative number right there, it cannot be equal to negative. That doesn't make sense for the distance. Once you see that after step 1, simplify, you stop and say no solution. To write that in set notation, you guys write the notation for empty set. It's a little circle with a slash through it. That's how you write no solution in set notation. And then interval notation is just an empty bracket. Nothing except. You gotta keep your eyes peeled. That's how they'll make it. Was super easy as we were going along, right? Everybody was kind of flowing along. This is how they make it tricky. There's always an extra complication with these things. It always seems too good to be true when it's super easy. So make sure you guys are paying attention. You cannot have an absolute value be equal to a negative number. You stop and say no solution. Okay? Is everybody okay with equality, solving these equations? I'm just going to switch just a teeny bit when we get to inequalities. So for these next two here and then the two on the top of the next page, we're going to be working with inequalities. So this is no longer an equal to. This is now going to be a greater than, a less than, a greater than or equal to, less than or equal to. One of those inequalities. The process is still the same. It's still simplify, split, solve. The only difference is what happens with the split step. I'll show you that in a second. How would I simplify this? One. I'm also going to go ahead and take the inside of the absolute value and rearrange it a little bit. I'm going to call it 5x plus 2. When I add the 1, it becomes greater than or equal to. You're allowed to rearrange inside the absolute value like that when it's addition because of the commutative property. When it's negative, you guys have to be more careful when you guys switch to make sure that the negative stays where it's supposed to be with the expression. You don't have to. Alright, so now we're here. That's the simplified step, the absolute value by itself. Now we're going to do the split. Okay? When you write the split, remember how we had a positive and a negative version? Okay? When I write the positive version, it's going to look identical to the absolute value expression, just without the absolute value bars. Okay? The other one is still going to be 5x plus 2. What do you think is going to happen to the inequality? Split. Because that one's negative. So when you guys do this split step, there's an extra complication you need to pay attention to. The positive one stays exactly the same. When you guys write the negative version, you have to reverse the direction of the inequality as well as add that. So that's a tiny little extra step you guys need to remember. And then the rest of it is normal when you guys are solving. So you subtract the 2 and then divide by 5. So if you subtract 2, you get a 0. And then divide it by 5 is still 0. So that's 0. And then I'm going to subtract, so it's going to be negative 4. Negative 4 divided by 5 is negative 0.8. Is this one going to be and or? Or, because when you guys did the simplify step, always base it on the simplify, not the phrasing question. After simplify, is it grade 4 then? So I'm going to use the word or. So it's this or that. I'm going to be looking for the word. Especially because when you guys write the set notation, you would use the actual word when it's before. So you need to make sure you guys know when to use the other word. So let's go ahead and graph it first. Because again, it makes it a lot easier to do the other parts if you graph it. So how would I graph x is greater than or equal to 0? I'm going to call this right here 0. What kind of circle? Closed circle is 0. And if I want it to be greater than? That way. And then I have right here, I'm going to call that negative 0.8. And I want it to be less than or equal to that. Closed circle. Remember, your OR graph is like this. Separated going like this. Because you subtract the 2 and 3 by the 7. Alright, everybody okay with the graph? Alright, let's do the set notation. The set notation is really easy. If you guys have written this already, you literally just write it down again. With the stupid graph. So you're just going to say x is greater than or equal to 0 or x is less than or equal to negative 0.8. Just write what you have for answer all over again. Now, look at your graph. Translate that into interval notation, just like we did for my unit. What's the furthest on the left? And then as it continues going this way, it gets up to equal or not. I use a bracket, and then I jump over the empty space, pick up at 0, and continue. So what's the first thing you would do for number 6? Okay, subtract 3, you get here, then what? Divide by negative 1/2, which is the same thing as multiplying by negative 2 to get an out. What happens to an inequality symbol when you guys multiply or divide by negative 3? Hope everybody caught that. This is now where you should be. The absolute value of x minus 4 is less than 1. That's what I x minus 1. Okay? Whenever you guys multiply or divide by negative, you have to remember how to work with inequalities algebraically. You have to switch where the direction of the inequality is. So now we're here. Now what do I do? Split. So I'm simplifying. I'm going to split. My first equation should look identical to what was over here minus the absolute value first. Then what? What does the second one look like? Right. For the second one, you have to reverse the inequalities. You used to have one of each. But they should never be the same. You have one of each for your equations, and then this one where you flip the inequalities should be negative. And remember, whatever's on the left side that was inside the absolute value bars, that was protected inside the castle, so that never changes. Never. So this was simplify, split, and I'm going to solve. So if I add 1, it's 5. And then if I add 1 here, 3. Is the word going to be and or? So there are two ways you could graph this to see what your graph looks like, or you guys can just look at the result after the simplify. Is this a less than or a greater than symbol? Less than. Whenever it's less than, the word is and. I know in the original question it was a greater than, but when you did the simplify, it changed. So always when you guys are trying to determine whether it's an and or an or based on what the expression or equation or inequality looks like, always look at it after you simplified, not before. So because it's turned into a less than situation after simplifying, that's why it's again. You can also see that in the graph it. So if we call this -3 and we call this 5, I'm going to be less than 5 but greater than -3, so that's the little part that's inside. So that's the end graph. Alright, set notation. Because this is an and graph and your x values are between two numbers, that's the inequality sandwich. Like this. Remember when x is between two numbers, left and right, you use the inequality sandwich setup. And then the integral notation, what should that look like? Yep. No brackets because there's no equality. Right, so yes, the inequalities are more complicated. There are more details you guys need to pay attention to, the ands versus the ors, being careful when you guys are simplifying whether it changes direction or not, the negative. You guys have to be really, really careful when you're working with those.
So we can divide it into
Yes. Symbol, inequality symbol, switch instruction. Great. On the top of the next page, these are two special cases. Let's put some nice big stars next to these two. These are special cases. Kind of like that one where we saw equals -2 for the equation where we said there's no solution. These are special cases like that. So for this one, what would happen if I do the simplify step? You always simplify first, if you can. I'm going to add 2, divide by -2. So what happens if you divide by -2? Flip it, becomes -1. Okay. So now let's think about this logically again. This is saying that the distance of this expression from 0 is less than -1. What kind of numbers are less than -1? Still negative. Again, can you have a distance be negative? No. So what do you think would happen if you say that it's less than -3? No solution. So if you want to write in the margin somewhere, either here or back where we had the no solution for the other question, it will always be no solution if it's equal to a negative number or less than a negative number. Always no solution in those two situations. So whenever you guys simplify and you see that it's either less than a negative number or it's equal to a negative number, automatic no solution. So it takes some of the work away. You don't have to do the split and solve stuff. You just have to simplify it, look for that little special case, and then quickly write down the solution and then move on. Okay? So when it's equal to a negative number or it's less than a negative number, no solution. Write that down, you're going to forget. Alright, what about this one? I can't simplify it. I've already simplified, that's cool. But this time it's greater than a negative number. Greater than a negative number. So it is possible. So numbers that are greater than -3 could still be negative. You could have -2, -1. But if we're thinking about this, shouldn't the absolute value, the answer for absolute value should always be positive, right? Are all positive numbers that exist greater than -3? So if you plug in any x that you want, doesn't matter, any x in the entire world, if you plug that in and take the absolute value of that, will that positive number always be greater than -3? So what do you think the answer would be for this? All real numbers. Every single x that exists, if you plug that in and take the absolute value, you get a positive number. That's always greater than a negative number. So this one is all real. All real numbers. And the way that you write that in set builder. There's this fancy R, it's like an R with two vertical lines, that just means x is equal to all real numbers. You could also say x is between negative infinity or positive infinity, that's another way of saying it. And the interval notation is exactly that. Doesn't matter. Doesn't matter. So it doesn't matter what's inside of the absolute value. Remember when you take the absolute value of either a positive or a negative number, the answer ends up being positive regardless? Like if I take the absolute value of -5, Negative on the inside, but how far away from 0 is negative 5? 5. So whether it's negative or positive inside the absolute value doesn't matter. Yeah, so it doesn't matter what the expression is. It'll turn out to be negative or positive inside the absolute value, but that doesn't matter. Was that what you were asking? Yes. Check every single time when you guys are working with inequalities. Check to see, especially if you get a negative here. If the number over there is positive, just move on. You're fine. You don't have to worry about this. But if you guys, in the simplified step, if you get a negative over here, check to see if it's less than or greater than, because it's either going to be one of these. So be super careful when you guys start to see negatives show up on that side in the simplified step. Right, and also this one, when you guys graph it, this one doesn't have a graph because there's no solution, but this one is every single number that exists, so you would just trace the number line. It's every single number. Okay? Right, so that's solving with your equations and your inequalities. What questions do we have about either of those? Yeah. Okay. We're going to do some quick, kind of more abstract ideas to see if this is really safe. What I want you guys to do is I have these expressions that are the same except for what. Alright, hopefully number 1 should have been easy. What's the only one that could possibly be a solution for number 1? B, that's the only one that has equality. Number 2, that one is a greater or equal to situation. So what word is going to be associated with the solution? Greater or. So which one of these doesn't work? That should have been obvious too. That made me solve it. This one says the absolute value is less than negative 4. No solution. It can't be less than a negative number for absolute value. That's for one of the situations you need to look out for. What about absolute value is greater than negative 4? All real numbers. Remember, that's one of our special cases. Anytime you have a negative on this side for your absolute value equation or inequality, you have to think of one of those two scenarios. What about this one is less than 4? What word is associated with less than? And? So which one of these ands would work? Why not C? Yeah, because this has equality, and this one doesn't. Okay. This one would be A. And this one says absolute value is equal to negative 4. Equal to negative. That one's no solution. Can't be equal to a negative number. Remember, the two that are no solution is when you're equal to or less than a negative number. Greater than a negative number is all real numbers. Alright. So you can figure that out. You can match up whether it's and or just by looking at these and finding expressions. Alright, now I'm just going to practice interval notation with you guys. I left out the word interval. Sorry. So I'm going to use interval notation for this. How would I write that? If I was solving absolute value and it gets to the end and that's my graph looks like, how would I write that in interval notation? Okay. Union. Remember, when you guys have that empty gap, union. And the arrows are infinities. Left arrow, negative infinity, positive arrow. Sorry. Yeah, negative infinities over here, positive infinities over here. What about this one? Square bracket 0. This, you would never get this as a solution for absolute value because they're either both going to be closed or both open. I was just making sure with this one you guys are paying attention whether it should be bracket or not. So that wouldn't be a solution to absolute value. It's just Alright, now these next two are interesting because these are SOL questions and kind of gotcha questions that you guys might see. Anything that's on here is fair game for the test. Make sure you guys are paying attention. So what this wants you to do is to solve, and then you're going to circle all the numbers that could be solutions. Okay? So let's do the solution process like we normally would, and then we'll go back to that table. So what would I do first? Simplify, right? get the absolute value of this piece by itself. So I'm going to subtract 1, and then divide by 3. The 3 is positive, so you don't have to change the inequality. So x minus 2, absolute value. When I subtract the 1, it becomes 6. Divided by, okay, down here, you get 2. Again, you don't have to split the inequality to go with 2. So that's simplified. Now what? Split. I have x minus 2 is greater than 2, and then what's the other equation? Again, you need one of each. First one looks identical to the original expression, the second one's flipped. Then I solve. And then you guys can tell me, is this an and or an or scenario? Look at your simplified expression. Greater than. So before we actually answer the question, it's a really good idea for these questions to draw a little graph for yourself. Again, seeing the visual with the graph makes every kind of aspect of answering these follow-up questions a lot easier. So if I were to graph this, I would have 0 and 4. And then would my graph look like this with the connection in between, or the arrows going out? Arrows going out, that's an or. And they're not equal to, so we have open circles. So even though it didn't ask for a graph, always draw one. It just makes the thought process a lot easier if you have that visual. Now we're going to go through and we're going to circle all the numbers that would be included in our graph. Is 0 a solution? Why not? Because it's an open circle not equal to 0. Do not choose 0. What about 1? 1's in here in this little section right here that's not part of the solution, so I wouldn't choose 1. What about negative 1? Is negative 1 over here with the arrow? Okay, so that's 1. What about 5? 5 greater than 4? Cool. What about 6? Yeah. 6 greater than 4? Does that work? What about 3? No, 3 is in here in this gap area that we didn't include in our solution. What about negative 4? What about 2? So you guys can see with the visual, but double check on whether the numbers are in here in this gap that is not our solution, or they're on either side of the group. Okay? Let's do this last one real quick. Alright, simplify. I'm going to add the 2. Because it's inside the absolute value, you don't have to worry about it. All you care about is making sure that the absolute value is by itself. You're not going to worry about what's inside. All you do is add the 2. Then, when you guys do the split, you have the one that looks identical, drop the absolute value bars and then look identical, and this one where you switch everything so that the symbol and the number are opposite. Then, when I solve this one, what happens? Because the negative is in front of the x. That's what we can do. When you write the 2 equations that you're splitting, you don't have to write. You don't change anything that's inside of the absolute value. That's what we've been doing the entire time. It's inside the castle. You don't ever change what's inside of the absolute value bars, only the stuff on the outside. Move it right. Move it away. So this negative is inside the absolute value, so you don't touch it. Don't worry about that. You have a smiley face there for all I care. So once you're here, once the absolute value bars go away when you're actually doing the split step, then we can work with that negative to try to get it to solve. So again, when I want x to be positive here at this point in the problem solving, I will divide the negative away, only at this step. So that gives me the solution. And then what happens here? So what happens is we do deal with that negative, not at this step, we do deal with it when we do the split and solve, so it's going to affect how the inequalities end up as your final answer. So, when we were here, what word is that? It's an and. This is a less than, so it's going to be an and. So our graph, after an and graph is when it's in between, and because it's equal to, they're going to be closed circles. Once you decide what your answer is, you draw a little graph for yourself. Now we're going to go through and circle the numbers that will work. Is negative 1 in between -9 and 9 is 8. -10? No, -10 outside the solution. What about 0? 9. Why is 9 work for this one? Because it's a closed circle this time. So you're allowed to choose 9 because it's equal to. It wasn't up here, but for this scenario in the second question it is. What about 12? Not 12. 2? -9? Okay. So again, you gotta be careful. You could do that. It's debatable whether that's more or less work depending on how many answers you have as your options. Okay, so anytime